Okay. Hi. Good morning. My name is
Morning.
Hui Feng. Yes. It's nice meeting you at this interview level. Can I know something about you?
Yeah, sure. My name is Wayland, and currently I live in Toronto. And I think I have the multiple years for the full stack engineer experience, and I also was working for the big company like the Microsoft or the Shopify in Canada as well. So yeah, I always passionate about building some enterprise level applications and want to optimize with application performance and trying to solve a lot of the blockers or the errors or the issues in the applications with the teammates. So I think that's I'm passionate about myself. Yeah. So
Okay. Cool. Yeah. Currently, I work at Google Lens. So
okay.
I'm not sure if you are familiar with that, but now I think it's a trending product. So traditional Google is a text-based search engine. Now
Yeah.
we are developing more multimodal entries. Basically, you can take any pictures and use just the picture as a text as a query. So you do not need to explicitly type anything, but we can guess your intent and provide your search results. So
Oh.
that's something I'm working on. Yeah.
Okay. Okay.
Cool.
Cool.
Then we can start with this coding session. So
Yeah. Sure.
I will give you a not very difficult problem, but I may divide it into several steps. So at
Yeah.
each
Sure.
step, maybe you can consider as maybe I will set 3 levels, so you can conquer it one by one.
Okay.
Yeah, we will start it with a very simple one. Probably you already know that, but just
Oh.
let me know your thought. Okay, so I
Okay.
will
Sure.
write the problem statement here.
Okay. Okay. Yeah.
Okay, so you are given a sorted array and integer.
Oh,
For
sure.
example, we call it t. Return how many pairs whose sum equals t equals 2t.
Okay.
All right, so looks
Um,
familiar.
yeah, it's a look familiar, but I think before we jump into the specific question, so I think we want to clarify this one. So can you give me some simple example based on this one? So in case I am not misunderstand what you mean here.
Okay, I can give you a simple case, but it may not enumerate all the cases. So maybe you need to discover some corner cases by yourself. Yeah. For
Oh,
now,
sure.
give you a very basic example. For example, 1, 3, 5, 9, 13,
Mm-hmm.
20, something like this.
Mm-hmm.
And t equals, for example, let me find the number, for example, 16.
Okay, got it.
So in this case, there were 2 pairs.
Okay,
One is you may find it. One is 7 and 9,
okay,
and the other is 3 and 13.
okay.
Okay, the answer is 2. You just need to type 2.
Okay. Okay, got it. So, yeah, let me clarify this one. So you're saying we have the sorted array here. So, yeah, am I typing here? So, this array, it's sorted, but we contains all the items. It's will be the integer or is a positive integer, or we should consideration that a negative one. It's can I clarify that one?
Oh, sorry. Could you repeat it? What kind of integer are you asking?
Yeah, so I'm asking that in this array, into this array. So each of the items should be the positive integer, or it has to be considered the negative one, or we should consider some float, or it's definitely to define by
okay, definitely integer. So I have explicitly called out. It's just an integer. Yeah.
Oh yeah, I think yeah, your point out the integer is a t, right? So I'm asking the array in this item, but yeah, since you
okay, I see. Okay, I was yeah, just the
array
integer.
is the integer. Okay, got it. You already typing there, so I ignore this one. Okay, so let's clarify that input and output first. So I think the input, like your description here. So we have the array. Array list to contain and contain the other items, and for example this one, and sorry, and we have the integer, which means it's target. So yeah, so it's integer with a target, so with 16 maybe here, and we return like you said, sorry, we return like you said before. It's we only need to calculate how many pairs. So I assuming we return the integer as well. So with how many pairs, right? So return the integer. Yeah. So for example, I need to clear some edge cases. For example, maybe we don't find any edge cases here. So would you prefer me to return 0? Not have any pair. Get 0 or the none, if you prefer me to get
just 0. Yeah.
Oh, okay, got it. Yeah, so I think that's all the things I want to clarify for now. So do you think I'm missing something here? So I can just adding them more requirements here.
I think that's it. So I won't give too many tricks or traps like that, like formatting or something like this.
Oh, okay.
Yeah. So don't worry about that.
Okay, got it. So in these cases, I think we initiatively thought it's will be getting some brute force approaches, like we can doing some iterator the every element in the array using the two nested loops, but will be time complexity will be the n to 2 powers. So that's will be not acceptable in this cases, I think. So we I think I have the more optimized approaches based on that one. So we can leverage like the 2 pointers. So only have the one linear time complexity like the ON to iterator that whole array to find the how many pairs in there. So that sounds good to you.
So could you give me some more insights about the 2 pointers? What is it? Why you can use that?
Yeah, sure. So for example, I'm saying this time complexity with the ON 2 point here. I just thinking that's roughly thought like we have the starting with a 2 point, like we have the 2 point like left or the right side. So the right side will be iterator to the end of the array, and the left will be at the beginning of the array, and check the sum of the element to all through this like you can imagine it's like the window. So it's like these pointers will be some equal to the t, then will be increasing the count and move the both of the pointer inward. And if the sum is less than the t, then the left pointer to the right and to increase the sum. So like the condition we can determine what's the condition meet our requirements during this window. So that sounds good to you?
Maybe some. I'm not sure if it is slipped, but maybe some details not right, very correct. But let me clarify it. So, for example, you are proposing 2 pointers. For example, one is called left,
Yes.
CR called right. So at the very beginning, I assume you put the left point at the very beginning of the array, right?
Yeah.
Then what? Where is the other pointers?
Oh, okay. So for example, we have the three conditions to doing this one. So for example, the first one, I assuming here it's we have some if the sum to equal. Sorry, I just typing there.
What is sum? You haven't. I'm asking where is the right pointer. You haven't. Could you draw it
Yeah.
on?
Yeah. Sure. The first thing is here. It's left here, and right is coming here. Yeah,
Okay.
it's coming here. Yeah, that's will be the right one. Okay, and then we can doing that counter based on this window. So because we already have the whole windows here, right? So so if the first condition is the sum equal to the t, and we increase the count. So like we count to plus, and then we can move the both pointer inward, which means that we can move this one to here. Sorry, I am typing this arrow. Okay, sorry. How to delete this one? Yeah. So this will be this one, and this will be counting this one. So they will be shrink these windows when they meeting these requirements. And the second condition is like if the sum is less than the t. So for example, summer is less than the t. So we will be only to move the left side. Because why? Because we have the sorted array, right? So we want to not meeting this requirement. So we only moving the left pointer to the right. So we want to be so this will be the left move. Sorry.
Could you be more specific? Why you can only move the left point to right? Why you cannot move the right one?
Oh, because we have the sorted one, so we want to bigger items, including our range. So we don't want to decrease that right one, because the right one already have the end of the array, so it's a bigger item posting in there.
Okay.
Okay. So the third condition we can see. So if the sum it's bigger or equal bigger than the t, so we will move the the right side. So that will be the optimize the logical. I mentioned that before, because this will be the bigger than the one we want to list or the smaller item in this array. So that sounds good to you?
Okay. So could you concisely explain why this algorithm is has a time complexity O(n)?
Yeah, sure. So when we continue this until the left point is the greater or the equal to the right pointer, so we have the container like the left or manners the right. So when we meeting this requirement, so which means this the right pointer and the left pointer were meeting in the middle. So, or for example, middle, maybe they meeting the right range of extra. So we actually only iterate this whole array one time. So that's why the O(n) with the time context here.
Okay, now you can start coding. So
yeah, sure.
Yeah.
Can I comment these things? So
yeah, sure.
Okay, sorry. Yeah. So yeah, since they have the unnecessary input here, so I can delete them. So if you prefer me doing that one, so okay. Sorry. So for example, we can define our function like we call them name maybe more suitable like we call them the we can define the type first, and we can call them count pair. Count pairs, yeah, maybe this one, yeah, pair. Yeah, sorry, it's spelling wrong always. Okay, so we have the inputs that we have the agreements with the integer with the target, and the array contains all the items here. So we like we discussed now before. So we need the counter to saving all the things here, and we need the left pointer and right pointer. So we define that first. So like count, we have the 0 and left with 0 and right will be will be the array with the last one. And we define our iterator here, like we mentioned, is one here. So let's getting the sum, causing the current one. Okay. So let's determine that the condition we discussed that before. So when this sum with the target, then we will be getting the count plus, and the left moved and the right moved as well. Oh, sorry. Okay. Then we getting the second condition here. So sum smaller than target, then we can get the left move, and else we will be getting the right move. So yeah, so then we can after this iterator here, it seems right. Yeah, and we can return the counter with that using that buffer. So that sounds good to you?
Okay, this is the most basic version. So so far everything good to me, but actually you may miss some conditions. So in one situation, actually your algorithm does not work. So I may give you 1 minute. If you cannot think about it, I can tell you what's the main piece. Yeah.
You are saying I just missing some the edge cases.
Yeah, you may consider edge cases, but actually it is quite common. There is a quite common pattern in which your algorithm will not work.
Oh, yeah. I think that has the edge cases I not covering here. So for example, if we have the duplicate value to this one, so we will be skipping the duplicate value to ensure that unique pairs are counted. So that's the edge cases you mentioned here. I'm not covering.
Exactly. So
okay.
How do you think about it?
Yeah, sure. That's a definitely fair enough edge cases. So I'm thinking we can skipping that duplicate value to ensure the unique pairs are counted. So if our requirements is there. So for example, we have the 4 and the duplicate value with a 4, and we only counting the ones. So we now duplicate the count them. So that sounds good to you?
Could you write something so that I can better understand what you are talking about?
Yes. So I'm saying we can skip the duplicates. Duplicate value to ensure the unique pairs are counted. So that's what I mean here.
So actually, I may not want unique pairs. For example, let me give you another example. If you scroll down to the bottom of the stock, so for example, 2, 2, 2, 3, 3, 4, 4. So if I, for example, let me see this one. So if I asking t equals 5, so what? So do you think if I want to just count how many pairs, maybe we need to define what's the unique pairs. So just if the index are different, we consider that the pair are different. So in this case, I would say the number of pairs whose sum equals 5 should be 6.
Oh, so you're saying if the index is different, we're counting the valid pairs, right?
Right.
Okay. Okay. So I think that's fair enough. So if we counting that one will be not the shifting another logical we now cover here. So so we can doing the same things with the previous logical, but we need to revert a little bit. For example, we can so if we counting the different pairs, even they have the logical here, so we can along with use the previous logical. Do you think so? Because we're not skipping them at all. I just to need to counting them one by one. That sounds good to you?
So let me know what do you mean by one?
For example, we're counting here, right? So for example, it's a 2 and 3. It will be the valid one. And if we counting these pairs, like this one, increasing the 1, and the next step still the 2 and the 3. So will be the counting another one. So it's will be counting increase here. So we don't need to skipping anymore. So this logical should be valid.
I may not understand. So do you involve any pointer movement?
Yes, because for example here, okay. So this one, the first valid here. So this 2 and wait a minute, and this 3 will be the valid here. So when we counting this one, so for example, this will be counts the first one, and then the second one will be moving to another position like this one. So based on our logical, right? So and this one will be moving into there. So this will be the 2, this 2 and this 3 will be counting another one. So this will be counting the count will be the 2. So that's based on our logical right now. We're not skipping any duplicates that one. So that's our logical including here.
Wait. So by your logic, so could you go on with continue with your case? So then what's next? What's the next count?
Yeah, the next counts will be the doing the cause it's still the valid. So the 2 will be this one will be moving to this the second third 2 here, and the next the right one will be not going anywhere. So that will be still staying here. So that's will be the 2 and 3 will be the counting 3. Okay, you're saying 5. Okay, I got your point. So you're saying 5 is like we only moving the left side, but not moving the right side. They're still counting the different. Is that what you're saying?
No. Here 5 is the target. 5 is target. So did you still remember what I said? So for these cases, what would be the answer?
You're saying the previous one or
just this one? Just look at
okay.
So yeah, so I have clarified my requirement now. So we consider if any index is different, we consider a distinct pair. So by this definition, so what do you think what is the answer?
If based on my current logical, I think it will be the 1. Let me see. 1 and 4 here. It's 1 and.
Let's make it more simple. So maybe let's change it to 6. Still make target at 5. So what's the answer?
The answer should be 1, 2. Based on my logical, I think it's 2.
Do you think that's correct?
Maybe I don't fully understand what's your requirements here. So let me clarify here. So for your instance here, you are saying, for example, this one. So the 2 and 3 summarized with a 5, right? So if I only moving the left side with the second 2, and we can still pair with the private 3. That's what you're expecting.
Right. Do you think that index changes? Right.
Index
changes. So that's a distinct another pair.
Okay. Got it. Okay. So
in this case, how many pairs that are qualified?
Let me counting that one. The 1 here, and the second 1, 2, and 3, and 4. It's 4, right? So 4.
Right?
It's 4, right? So
not really.
Not really. Let me adding here. Sorry. Not adding here. The first, I'm seeing the index, right? So the index 2, 3, 4, 5, 6. And 6 will be the pair 1, and 3 will be the 6, will be the pair 2, right? So, and 3 and 4 with 6, right? So it's still the pair S3, right? So then we can continue with 4 and 5 with another one, and we also can getting the backing like this 3, 5. That's still the value, and the 2 with the 5. It's all the possibility here. You're saying?
Yeah. So the 6, which I previously mentioned earlier. Maybe you missed that, but I think definitely, it's clear that we should return 6 for this case. Yeah.
Okay.
So now you may revisit your logics and think about it.
Okay, got it. So we counting all the possibility with pairs, including even there has a duplicate value but different index. So that's our mainly things I'm thinking. Okay, that's fair enough. So based on this situation, I think I need to calculating the all the values, how many times they appear in this in the array. Then we can saving that how many pairs in some data structure. Then we can fetch them when we counting the pairs. That's fair enough to you? For example.
So suppose you have you know how many the frequency for a number which is pairs. Then what are you going to do with them?
Once we have them, so we getting the frequency based on this value, then we can multiple with the value we have. So for example, we have the how many 2? We have 3, 2 here, right? And we multiple the 2 times with the 3. It's a 6.
So okay. So could you code it? So
yeah, definitely. So
because we have a strict time limit, so maybe you should be quick. We have some follow-ups.
Yeah, no worries. I can think the integer was integer.
Oh, you are going to save the.
Yes. It's you want to me saving this step to only.
So
okay, got it.
So if you are using such a map, so what's the space complexity? So you may require.
That will be the ON. So
So if you have ON, let me think about this. Yeah. So suppose you can use ON space complexity, you may not even need 2 pointers, right?
I mean.
Okay, let's go a little back. Let's step back a little bit. So, for example, suppose you are allowed to use ON space complexity. Do you have other ways to solve this problem?
Oh, you're saying you want me to reduce the space complexity to the more
Yeah, that's my
efficient way?
argument go. But for here, for a side question, so if you are allowed to use ON space complexity, so
Okay.
will there be an even simpler solution?
Let me think about it.
Yeah, you may still
I am
right.
thinking
So
that
use
one.
this as example. So
Sorry.
if you are
Okay.
allowed to use ON space
Okay.
complexity.
Yeah, but our requirements not changes, right? So we also need to calculating that all the possibilities, right?
Right. Yeah.
Let me think about it. If I allow using the
ON space complexity.
okay,
There
okay.
would be a very, very simple solution.
Let me think about it. I just starting with some ideas that I saw that before, but yeah, I can think about it a little bit. So you're saying when we already counting the frequency with different values, and we can. Oh, okay. So may I clarify this one? So so you want me to reduce the space complexity or the time complexity here? So
Basically means if you are allowed to use ON space complexity, so you don't need 2 pointers. You can still use something. Let me be more specific. Just the ON time complexity. You can still do that, but you don't need to involve pointer movement or something. Some tricks like this. A very straightforward way.
okay. So if I allow using the ON, so which means I can saving all the frequency based on this this whole value. So but okay, but I still thinking the one thing here. So if we want to saving that all the frequency, actually we iterate the array one time, so it should be the ON here, the time complexity.
Yeah, definitely. Yeah. You still because your your array contains n elements.
Yes.
you can't solve it in O1 or even.
Yeah. So how do you think I can reduce the time complexity here?
I didn't say you can reduce time complexity. I just say you don't need 2 pointers. You can
Okay.
reduce the
Oh,
line.
yeah. Yeah, I got your wrong point. So I think you want me to reduce the time complexity.
No,
I
didn't
still,
say
yeah, okay. So yeah, in the one iterator here, so we can if like I said before, if we're using the hash map to saving all the elements here. So for example, we already have the save the elements counts with hash map. And we can now using we not allow, it's just we can using another iterator to through the array finder pairs. We don't use the 2 pointer, we only using the like the regular iterator here. For example, I can giving this one array maybe, and we counting the implementations here. So we count the how to say complement with a target to manage the numbers here. and we have this one to checking this values counts, including that one. So we can get or defer to getting this complement with the still values, or we have in there or not. So that's a basic one. Then we can doing the number and the complements are the same, so we can counting that formulation we defined up for like the multiples. Is that sound good to you? I can finish the code if you want.
Yeah, you don't need to finish it. Yes, that's basically what we want, but there is still a mistake in this code. So you cannot really doing exactly this thing. So could you think about it? So
you're saying I have the arrows here, so
right, the idea it's not 100% correct.
I using this way. It's like I like the two summaries way. Like if you have the complement here, so we can checking that equal to the numbers we current have. Then we can getting the counts to multiple the previous one and current one. So then we can have the else logical to checking that with a count 0 to avoiding the double count.
Okay, let me be more specific. So these lines, they are good. So this idea is good. So you see the problem. Where's the problem? Let's say about line for now, line 81. So for the case where we have duplicate numbers.
81.
Line 81. So now, yeah, just the example. The array contain duplicate numbers. Then look at the this pseudo code again. Did you see any issue? It's a small bug. Yeah, maybe just some carelessness, but that's crucial.
I'm saying if there's an arrow.
Maybe I missed your something. Could you complete this line? This line 55.
Oh yeah, sure. So this line will be if sorry, I'm typing 01. So this one will be the number equal to the complement. Then we can counting them, else we can doing some checking here. So this logical here, so when we getting the element, we call them this one value counts, right? So this
okay, so let's temporarily ignore this case. Let's assume this case not we don't really consider about this case. I just want to complete the most important one. So how do you increase the counter?
How do I when I saying we have the two things to calculate the counter. Yeah, since you did in my code. So when we have the if here, so we counting the code with count with the multiple with the n multiple that n minus 1 and divided 2, right? So and then sorry, what I was saying?
What is n? Sorry.
Yeah, I think you delayed my code. So yeah, let me. Okay, can I? No, I can restore that. Yeah, I'm just seeing this one. So yeah, so when we equal to them, so it's n I defined here. It's a value count. Value count to get the numbers, right? So sorry, get numbers, and then it's the n here. So I'm seeing the count. Oh, sorry, the count will be plus the n multiple the n minus n minus 1 to divided 2. So that's formulated here. And else, when we're doing this one, we count the count to plus that value count to get the number and multiple that element, the value counts to get the complement. Yeah, this one. This will be the two-way to count the numbers. Then we can setting the. We also need to setting that value counts to put them to 0 because we already counting them. So this one will be the 0, and also need to value counts to put the element as a comment as well. So this will be the 0 as well.
All right. So actually, what I mean is here. So this should be problematic. Typically, so consider we have limited time. So let me tell you. So if we combine this one with this one, these two lines actually conflict. Actually, there is problem with them.
Okay.
If you are if you are looping over the original array, and you are also counting in this way, then you see problem.
I'm getting the numbers and the value to get the complements here. I think when we counting there, I just setting them to 0. So what's the problem here? I didn't.
Sorry, I missed these two. So you are counting. Okay. I may miss these two lines. So okay, that's good. Actually, I may okay. Yes, this is fine for your C code. So prefix eval site should be very even simple. You just need to throw over the this hash map. Then I don't need to think. I don't think you need to modify this something in the code, right? Because in the hash map, the key is unique, right? You find a key and see if there's a matched complementary key.
Okay.
Right? Yes, that would be simple.
Oh, you're saying the saving the index instead of the number itself.
Yeah. Loop over the hash map.
Okay.
Loop over the key. Because key is unique, right? So basically, you just need to something you know how to loop over hash keys. I know how to do that in CPP, but I may not very familiar with Java.
You're saying we looping them. Okay. So based on your coding here, I think we not only saving the value but itself, but we also to saving the index here, right? So
correct.
Okay.
Basically something like this, but obviously you will be overcounting. Then you may do something like maybe cut it half, right?
Oh yeah. Because each of the item we actually counting the twice. So
yeah. So that's what I personally, if you use hash map, if you are allowed to use ON space complexity, the code could be significantly reduced. Okay, let's forget about this. Let's go back to the 2 pointers. That's my original intention. So okay, so that's why I told you. So if I don't like you to use such a hash map when you are already trying to use 2 pointers.
Okay.
Then can you do something like this, still based on this 2-point framework, like what I uncommented? So could you continue with that and implant your ideas how to resolve the issues about the duplicate numbers?
Oh, okay. So you're saying we allow use the 2-pointer approaches, but we were not using the ON space complexity.
Right. That's my original intention.
Okay, but requirements still remain the same, right?
Yeah. I didn't change the problem statement. Yeah.
Okay. Based on that one, I think we need to change the logical here. So for example, we have the equal here, and we want to counting that the duplicates index here. So Let me think about it. So we now move forward the index, but we having the I can assuming we so based on that one, so I'm thinking we can use the while loop to checking the duplicates for the left pointer and the right pointer separately. So that sounds good to you in this logical.
Okay.
So
Then
yeah.
could you quickly implement?
Yeah, sure. So for example, we have the left value here to get the left, and all right, to get right here. So okay, so we have the count left. We call them to counting the left side, and we count the right side. Was also currently already have one, so we counting them with one. So currently we want to counting the duplicates for left pointer. Okay, so with this while loop, so when we counting the next one, matching so yeah, we ensure that's not exiting so the range. So we left check with the left one, sorry, yeah, this one. So then we can doing the left move with the count left +1. Then we can doing the same logical with the right one. So I copy this one to here. It's right point, and this one will be the right, but with the -1, and it's bigger than the left. Then we can doing the rewrite to doing that left right to -1, and this one will be the right. And then we can counting the right. The right to bigger than that. Then we can, when we counting this one, so we want to ensure that elements still the same. So if the elements are same, so okay, so when we get the left side equal to the right side, then we can use some of the formulation without defined up before, because we need to calculate in this scenario. So for example, we have the how to say combination, maybe, yeah, combination to counting that count left to multiples count right. Yeah, count left, sorry, it's the same one. Count left -1, and we can divide it 2 for duplicates, and then we can get the count to aiding that's a combination here. Else, if there's a not-same, so we can get the count to count left to multiples count right. That should be the logical, but we also needing this movement after this calculation. So left moves, and then we can doing the right moves as well. Then we can target still the same. Yeah, I think that's the logical we want to cover here. All right, this one. That makes sense to you?
Okay, so the basic idea looks good. Though I may see your code might be a little bit complex, and I may say it might be bug prone. For example, I'm not quite sure now, but I may see a bug. I'm running the code in my mind now. So I feel the code might be risk. Let me see about it. So might be risk. Okay, I think it will be risk. Yeah. So okay, I may not be right, but I may really want to try this case. So if we look at the bottom, I'm creating a test case, something like t equals 4. So in your code, so suppose we find the first one, 1 and 3. Okay, so here, then you move it to here, then move it to here, right? So now you are going to move left pointers, right?
So I think it's this one is now moving. You're referring the 6-4 lines here, right? It's not moving. It's just checking the next one will be still the valid. So we only to getting the left one after it's a valid checking, then we can counting the left one, right? So sorry, count the left side.
Okay, so just go back to the line 104. So in this case, will you move the left pointers towards right?
Sorry, which line you're referring? Okay.
104. So
104. Okay.
Okay. So I assume when I read your code, I think so your pointer will go straight here. Did I understand it right?
Yes.
Okay, so you see the problem? I may see the problem. So in this case, the left count equals how many? 1, 2, 3, 4.
Okay. 4. Okay, you can.
And are you going to move your right point? Maybe no. I don't think so. If you look at line 75, you won't move your right pointer because this one, right minus 1 will be equal to left. So you won't execute this part.
Yes.
So your right pointer will stay. So you go back to 105, look at this point, this diagram. So okay, your right point still left get there. So right count equals 1.
Okay.
So in this case, when you increase the counter, you see problem, you will increase something like this, right? Let me check your code. So your code in line 80.
This one it's under the condition is if the left and the right index is the same, right? So I just want checking the elements are the same.
If you're talking about the line 79, you are checking the value. The value are the same, right? They're both 2. So you are adding this one, right?
Okay. Yes.
So actually, there's a bug, right?
Yeah, but your multiple the 1 here, right? So I multiple the count left minus 1.
Okay. Then something like 4, right? Is this what you? But that should be the right one, no, right? So ideally, we should be what 5 times 4 divided by 2. Right, there are 5 2s. If you want to pick any 2 of them,
yes,
there should be 5 times 4 divided by 2, such number of pairs.
Yeah, let me clarify the counting. I'm thinking this while loop here, it's increase the left side will be when I stay in the index you're seeing here is the second one, and we actually the left side it's a 1, right? So right now, and we increase the left side with 1, 2, 3, 4, And for because we have the three of so multiples of 3. May I ask this question?
So I just want to know if did you see there is a bug or not?
Seems I didn't see the.
You didn't see the bug?
Yeah.
Okay. So maybe we need to discuss line 65.
Okay.
So after executing this block, where is the left pointer? So let's go back to the line 105.
Okay.
So is the left pointer supposed to be here or supposed to be here? It cannot be here, right? Because you need left plus 1 is smaller than right. So it must stop here.
Yes.
So then what's the left counter?
May I ask one thing here? So I'm thinking your right counter it's a pointer to the Q value. So I think I want to clarify that's the first. So I'm thinking the first should be this pointer the 3, right? So
yeah. Let's assume skip 3. So X first is 1 and 3, right? So now there's pairs.
Yes.
Now you should move both pointers.
Yes.
So then it looks like this, right?
Yes.
Okay, so that's no problem. Then based on your code, you only move left pointers towards here, and the right pointers will not move.
Yeah, because I checked the valid here, so that's +1 is smaller than the right one. Oh yeah, that should be should be minus equal, right? So
I think this kind of code is very bug prone. So you are not using very elegant code to do that. So if I were you, I may just maybe I can I can show what we'll do. So in your code in line 58, so I may do say something like this: use a temporary pointers. Just let it go, right? While I see.
Yeah, I'm saying.
Yeah, I'm trying to give you something what I want to do. So actually, in this case, there's an even simpler method. So you can direct check here. Then what we'll do? So you know how many duplicate numbers here, right? Then directly count. Then return or break. Because left and right points are really the same. All the numbers between them are the same. So just break it. That's okay. Then your other code are still valid, I assume. But you are still overcomplicated the logic. But you may simply maybe cut the line by 2 or something. Yeah. But basically, what I mean is that for the case like 2 + 2 = 4, you can just use this one.
Okay.
Yeah. Otherwise, it will be tangled with other logic to make it the code bug prone. Okay. Then yes, it's already an hour. So actually, previously I said there was 3 sessions, right? So maybe you don't have enough time, but I would like to let you know what's the upcoming problem. So if you go back to the line 1, I will slightly modify the problem statement a little bit. So you are given a sorted array by its absolute values. then in this case, how would you still use 2 pointers to solve this problem? That's my third level. Yeah, usually 90% of interviews may not come to this level. Yeah.
Oh, okay. Okay.
Yeah. So you may think about it in your spare time. So if you can come to this problem, and maybe you don't have enough time, but if you can state out your thoughts, if there's a plausible solution, then I may give you a strong high. Yeah. Okay. So maybe we can give a summary. Yeah, it's right 1 hour now. Let's switch back to the Chinese language channel. 好，总的来说呢，总的来说，一开始我觉得沟通还是比较流畅的啊，节奏也比较好，特别是当你完成到第一个最简单的那个 2-point forging 的时候，大概用了15到20分钟的时间，这是在我的预期之中的。我掌握就是说前面所有的寒暄包括一些这个题目的理解，然后最基本的一个 2-point 的解法，20分钟最好是15分钟，15到20分钟差不多。然后接下来呢，我会预期到会有刚才说的这个问题，就是说 duplicate numbers 问题。这个问题几乎是所有的候选人，80%候选人都是一开始是不会想到这个的。那么当然我也不会拿这个作为扣分点，就是说就像我说的，就是说如果你1分钟想不到，我会告诉你你需要考虑一下这个东西。那么考虑到这个东西的时候，主要就考察，就是说这个候选人就面试人是不是能够很快的对这个 case 调整算法。但是今天在这个我们的面试当中出了一点我没有预料到的是什么呢？就是说你想到要用一个 hash map 来统计它的频率。因为那时候我以前面试人的时候都是说照着 2-point 的思路想，就问题就集中在如何统计如何就移动 pointers 来记这些 duplicate numbers。你突然提到了这 hash map，正好我也兴致来了，我就突然想问一下你这 hash map， 就是说只用 hash map 怎么来做这东西？这个东西好像耽搁时间有点长，好像咱们这个没有在一个频道上面。
对，因为我以为你让我就是减少那个时间复杂度，然后我实在没想明白为什么怎么。
对，如果你复盘看视频的话，你应该发现我压根没说要减少时间复杂度，是你想当然了。这一点是好像思维惯性，对这一点稍微注意，一定要100%理解面试官想要的是什么，是吧？面试官想要的其实就非常简单的一个类似于这样子的东西，我甚至不会要求你来写，因为我觉得这可能会花点时间。就是如果你能说我们就只要统计一下频次，找到一个再弄一个，是不是？对，你只要把这个能够快速说一下，我就会过了。但是呢，不知道怎么搞的，最后开始写代码了。你一写代码的话，我就觉得，我就觉得好像有 bug 可以抓。当然，好像后来试试看，好像确实不是你的 bug， 但是感觉好像确实跟我讲的比较跑偏了。我本来想大概就这样，就是 loop over 这个 hash map 就行了。结果你还是 loop 的这个 original 这个 array。那么我当时没想到你会把 hash map 又改了，所以说我可能一开始觉得你有 bug， 但实际上那个时候那确实没有 bug 了。但是代码呢，可能稍微有点出乎我的意料。所以说总的来说呢，这个插曲导致了节奏就打乱了。然后等回到我们这 2-point 的时候呢，很明显就是你也没有能够第一时间肯给出一个 very elegant 的一个 solution， 是不是？你写的这个东西呢，这个东西怎么说呢？我一开始是不想让你考虑这个东西的。看一下 187， 这个东西我本来是想留到再下一个 corner case， 因为并不是所有的面试人都想到这个东西的。所以说我只要你想到类似于这样子，就达到我这一关的目的了。然后我会再问说，如果像这种2+2等于4这种 case 怎么办？然后我会其实再会提早把这个59行这个东西给搬出来，说你只要加一个这个东西，代码就非常 clean 了。但是你那个提前想到了以后就肯办在就是87行，现在这边肯办到这里，这就很容易出 bug 了，而且你很不幸被我给抓住了。事实上并不是所有的那个面试官都愿意脑子跑一遍，可能今天我刚起床，所以脑子特别好使，所以说我一眼就看出你这个问题来了。如果可能面试官工作一天了，可能就是觉得组件代码怪怪的，但是他不愿意细想，那你可能就过了但今天你只要很不幸被我抓住了，还揪着这个东西 算了半天，大概至少浪费了5到10分钟，是不是？就是说这时间也是浪费掉，是不是？这很可惜。所以说这2点啊，这几点差距导致时间的这个推迟啊。事实上，本来这道题其实非常简单的，是不是？如果你真的是很盲目的刷子的话，那这种题目直接背答案就很快就出来了。但是呢，在交流过程中，确实很容易发现隐藏的东西啊。那么最后回到最后，就是一开头就是第一行那边就是这个 follow up， 就是最后的 boss 关啊。我只见过一个人是打到这个 boss 关了，然后呢说了，在我提示下说了一些正确的想法啊，但是肯定也没时间那个考虑了。该怎么理解？如果现在你有时间啊，用中文你觉得你会有些什么想法
？So yeah， 不是，我还是用中文。OK， 我在想，
我举个例子来帮你思考一下啊，它是比如说类似于这种，对吧？然后你随便选一个 target，比如说这个叫负2吧，这种情况下该怎么处理？很明显我其实还是希望你弄 two pointers， 但是 two points 显然直接 two points 是不适用的，是吧？你觉得这时候如果这样的话，我一般会提醒面试者说，我怎么样更改一下，使得原来的这个算法就是那种就是 truly sorted 的这个 array 呢依然适用。
那我原来的 truly sorted， 就是说还是 two pointer 那个吗？还是？
对，原来 two point 的要求是什么呢？必须是 truly sorted 的这个 array 我才能用那种算法，是吧？
对。
现在并不是一个 truly sorted 的，它是 sorted by absolute value。
对，我想想，如果是这样的话，我们可能需要改一下，就是我们就我的想法就可能比较简单，就是还是 count 这个 frequency， 然后用 HashiMap， 然后我们找那个 pair 的时候，就是你这个就是还是用我之前
那跟之前就没有任何区别啊。
OK，
HashiMap 其实根本就不关心是不是 sorted 的。
对，所以我再想想，对，它不是 sorted，
其实解法思路很简单啊，代码可能稍微有点长，但是思路非常简单，就是我们只找其中的 sorted subsequence。什么意思呢？就是你要找一对嘛，那么就只找，比如说这2对，这2个都是正的。那如果你只看正的元素，它只看这里面正的元素，它是不是一个 sorted 的？
是。
如果只看2个都是负的，是不是在这里边也是 sorted 的？当然它是逆 sorted 的啊，但是原理也是一样，是不是啊？如果是一正一负呢？一正一负其实就是一个快慢，就是单向指针了，是吧？就是一个只看正，一个只看负，是不是？然后同理，它们的移动都是一样的，是不是？对，都是往那，都往同向移动的啊。就是这就要分情况讨论了啊。但是其实大量代码是可以复用的啊。所以说这主要就是看一个人思路，就是说能不能想到，就是说找他 subsequence 啊。对，就是这样一个想法。
明白。
好，那么这就是基本上的这个我的一个 feedback。总的来说的话，我可能会给一个 high 吧，因为总的感觉的话，沟通还可以，是吧？那写代码呢，那没有看出来什么，当然因为这代码本来也简单，不需要什么太多复杂的语法什么的，也查出什么太多的问题来。对，那么主要就是在一些压力下啊，在压力下一些 case 一些 debug 的这个敏锐度呢，可能就差一点。那当然我也理解啊，确实在就是面试环境下就很难保持头脑的这种敏锐。对，主要是因为时间长了。如果我们 go back 到视频大概40分钟的时候 ，cut 在40分钟的时候，那时候我们在哪里啊？我觉得可能好像。
可能在说那个 HashiMap 那个地方。
对，还在说 HashiMap，甚至连这个你这 count 都没有 这个 2 point 这个东西都没有到，这就可能有点危险啊，我觉得有点危险。对，但是如果 extend 到这个 1 hour 这表现的话，我觉得还是可以给个 weak high 到 high，反正这就是我面试风格，我不会出特别偏门的这些东西，就是说我可能会出类似这种突破的，一开始让这个被面试人觉得啊很 easy， 是不是啊？然后可能会有点放松警惕啊，突然一下意想不到一些问题，比如说 duplicate numbers 啊，或者说2+2=4啊这种 case，对，我会从中观察面试者的表现。
明白。
总的来说的话，就是对，还有一个就是说一定要把握好时间节奏，就是说你认为你非常熟练的，你就不需要特别长篇的大论啊，当然你必须也要说话，展现出你对这个非常熟练、非常了解，但是呢，你肯定要适当把握住这个节奏，就是说最好是能够在面试前问一下面试官，说今天有几轮几道题，是不是？你 expect me 多少时间花在这上面，是吧？像我一开始跟你说，其实我这个3轮，就是说你可能需要时间上的这个把握，你觉得说你要意识到，第一个这个 point 不会是那么简单，是吧？不会说我花掉将近半个小时做这道题目，我必须要快速的 move on。对，这个点时间最好能把握一下啊。其他我感觉都还可以吧。对，主要面试比较顺畅，是不是？这个沟通交流，我问什么，你基本上答的都还是比较到点上面的啊。对，可以，基本上这就是我个人一个打算啊，我的一个感受吧。
好，
行，
那我再改进一下自己的这个想法什么的。
对，然后我这个视频应该也是录了啊，待会儿我会把这个，我看怎么 share 给你，我想办法 share 给你吧，如果你需要的话可以回看一下啊。
好的。好，
如果你还有什么问题的话，可以随时微信跟我聊一下。
好的，好，谢谢啊。
OK，好，就这样，拜拜。